Hello and welcome to this webinar about Spark. This is one of a number of introductory webinars about big data being run by the UK Data Service. I'm Sarah King-Heel and I work at the University of Manchester in training and user support. Peter Smythe is going to do most of the presenting today, however. He's also based at Manchester University and also works for training and support for the UK Data Service.
Thank you, Sarah, and we'll get straight into the webinar. Today, as Sarah just said, we're talking about Spark, and what we're going to look at are what makes Spark different from other Hadoop products. We'll have a brief look at the Spark framework and APIs just to give an idea of how it all fits together. An API stands for Application Programming Environment, and it's just a way of allowing Spark to integrate with other programming languages. And then hopefully the majority of the webinar we'll see some examples of using Spark R in both a Windows environment and in a Hadoop sandbox. The Hadoop sandbox is a single machine Hadoop environment which allows you to pretend you have a large cluster when in reality all you really have is a single PC. So moving on, brief history of Spark. Even big data itself, or big data processing, really only goes back to 2002 with the Hutch project, which was aimed at finding ways of processing very large data sets in a reasonable amount of time and using parallel processing. So that's the notion of a cluster of many machines, thousands of machines potentially, all working together to process very large data sets by breaking it down into small chunks and processing in parallel. And from that project, Doug Cutting, who was at Yahoo at the time, produced papers on the process called MapReduce, which is this idea of breaking down the processing across a variety of machines and making them all work together. And MapReduce was really the basis of Apache Hadoop in 2008. That was the main way of processing any kind of data. The downside of MapReduce is it's very batch oriented. So you set up a job, you run the job, you set up another job, you run that job, and so on and so forth. It wasn't particularly interactive. In 2009, a gentleman called Matai Saharia at UK Berkeley wrote a paper as part of his PhD thesis on using this product called, or invented a product called Spark, which the idea was that it would combine all the different types of processing available in Hadoop into a single system, and it would be far more interactive and a lot quicker than the MapReduce systems that were current at the time. It proved very successful, and in 2013 he actually created a company called Databricks, whose sole purpose in life is to market the uses of Spark, and it's gone through a number of iterations in the process. And it was also about that same time handed over to Apache to distribute Spark under an open source license. And so when we use Spark now, we actually download it from Apache site, but a lot of the development work is still undertaken by the people at Databricks, and all the original founders of Spark, I believe, are still there. So because Spark is very new and very fast moving, it can be quite difficult to keep up to date with the documentation. There's plenty of books on Spark, but they tend to be almost out of date before they're printed because of this fast moving environment in which it's set up in. So if you want to know about Spark, one of the best places to go is the source, if you like, which is currently at sparkapache.org. And if you go there, this is the front screen that you'll see. But rather than just show you a slide, if we actually go to the website, so this is the same screen here, and on this initial page at sparkapache.org, it will tell you various things about the speed of Spark, how easy it is to use. So this is sort of referring to the different APIs which allow you to use it in different languages. how the generality of it, that you can use it with SQL and streaming and complex analytics. SQL, structured query language, is almost a de facto way for processing structured data, that is data in tables, in relational database systems and so on. Streaming refers to real-time processing, so data coming in constantly. So you can think of Twitter as being a source of streaming data, because Twitters are being generated every second of the day. New ones are constantly coming along. Another advantage of Spark is that it runs everywhere. Now, it runs on Hadoop, as that's where it started, but it will also run on other environments as well, and certainly we're going to see it running in a standalone mode on a Windows machine in a few minutes. But it can also access diverse data sources, so simple files on your PC, which again we'll see, simple files in on other machines in a cluster, so it will interface with HDFS, which is the file system used by Hadoop systems. Stands for Hadoop Distributed File System, and there's various other types of data sources which Spark can interface with. So that's the advertising blurb for the product. If you come down to the bottom of the screen, it will also give you information on mailing lists where you can get additional information. You can download Spark from here. There's quick start guides, there's training videos, and various other things which will be useful to anyone starting off in Spark. And that's just the front page. So if you actually want specific documentation on your release of Spark, if we go to other resources here, you see these are all of the earlier releases. At this point here, about 1.1, that's only 2 years ago. All this has come out in the last 2 years. The one we're going to be using is Spark 1.6.0. We'll look at that in a minute, but you can see again here, it's got lists of videos that you can watch, various training materials, exercises. It's got a list of books. Like I say, a lot of these books may already be out of date, in that there'll be further releases of Spark to look at, but of course the core elements of Spark won't change, so all of these books potentially could be of use to you. Examples, again, when you install Spark, it comes with a whole series of examples which you can run yourself just to get an idea, and of course all the source code's included, so you'll be able to look at how these programs have been put together and use them as a basis of your own. There's a wiki, and these are the various research papers. If you then go into the actual documentation for the release we're using, Spark 1.6, and then under here we've got various programming guides which you can look at for the various parts, different APIs within the Spark framework. You can look at the APIs for the specific language that you're interested in, so we'll be using R later on. So if you click on there, you can see a whole list of all of the functions available to the Spark R user. There's quite a few there, but by far Spark R is the least function rich of the various dialects at the moment, but there's still quite a lot of things you can do, and if you need to dig in, you can look at the individual descriptions that are provided there. Okay, if you look at the programming guides, Spark programming guides, this is just a general one. You get a general overview of how Spark works in various ways, and all of them will have examples in the different languages available. At the moment there's not much in here for Spark R, because Spark R is relatively new, but if you go to the Spark, the R API doc, you'll be able to find examples of that. Okay, so just to come back to the slides briefly. There we are. So documentation. So really, what is different about Spark? It's really, I could have just copied that front page of the Spark documentation, because what Spark is aiming to do is a complete processing framework for big data. So in that sense, it replaces several of individual Hadoop components, which I'll show you in a minute. It's got APIs available for several languages, so that's the ones that we've just seen. And of course, that makes the introduction of Spark into those languages just the same as adding a package to R or Python or something like that. So it's very, in that sense, it represents a very short learning curve for people who want to start using Spark. It's scalable to very large data sets. Now, of course, that's the whole point of big data. Whatever you do, you've got to be able to do it on a very, very large data set, so that data sets which can only effectively be processed on clusters. And like the other big data solutions, the point about Spark when you're actually coding to work against your data set, although in our examples here, we're going to use a very simple Windows PC or Hadoop sandbox. The point A is that the code that you write is exactly the same code as you would need to write if your data set was hundreds of gigabytes spread across thousands of PCs, of thousands of machines in a cluster. To you, it all looks the same. In fact, what it looks like is just a big table, your data set. We saw a little bit about the speed, 10 to 100 times faster than MapReduce. What Spark tries to do is it tries to do all of its processing in memory. So if you can eliminate toing and throwing to disks, then you're clearly going to have a massive increase in speed in the processing, and that's hopefully what it tries to do. Now, I have seen claims for real-time processing and real-time responses, but we're not going to see that today on our little sandbox in Windows PC. You can also run Spark on virtually anything. So Hadoop cluster is obvious, that's where it was originally designed to use, but you can run it on a Windows PC, as we'll see, and if you really want to, you can run it on a Raspberry Pi as well. You will have a few memory problems, but it can run. So let's try and compare how Spark tries to encompass the various elements that you might find in a more traditional Hadoop environment. So if we start off with Hadoop, Hadoop itself is little more than the MapReduce processing engine and the distributed file system, HDFS. So on top of Hadoop, you will typically find running things like Hive, which is allows you to treat your data as tables, SQL-like tables. We've got Pig, which is again a very data manipulation type language. We've got Mahout, which is used for statistical analysis or machine learning. So there's a whole set of dedicated algorithms within Mahout. We've got Flume, which is one of the several products available for processing streaming data coming into whatever system. And we've got something called Apache Giraffe, which is used for dealing with graphics databases. Now, graphics databases, in this sense, it's talking about a database structure. It's nothing to do with visualization. They're used for things like mapping social networks and so on. Now, so that's just 5 products we've listed there. And the idea of Spark is that you can use Spark to do all of the types of functions that those 5 products will do for you. So the Spark framework, it starts with some core elements of Spark, which is just general processing type things. And on top of that, we've effectively got 4 pillars of functionality. We've got Spark SQL, which allows you to do the SQL type processing tasks. We've got Spark Streaming, so that's streaming data. We've got MLlib, which is machine learning or statistical analysis. So that's your clustering algorithms and things like that. And then we've got GraphX, which does the graphing database. And across all of those, we have data frames. And data frames are the part of Spark which allows you to treat everything as, from the user's point of view, as a table. Internally, a data frame in Spark is it's not quite the same, but it equates to what Spark refers to as an RDD, resilient distributed data set. Now, the point of a resilient data set is that is what allows Spark to do the distributed processing which you would need to be able to do on a cluster, and it also provides you with fault tolerance in cases of data losses or machines going down and so on. And that's very similar to the type of things that Hadoop will provide in HDFS. But from the user's point of view, the point about data frames is, again, it looks like your entire data set just looks like a table, and to a large extent you can treat it in that way. Everything else is hidden from you because you don't really want to get too involved with having to make changes to your code to decide how big the cluster array is or anything silly like that. You just want to be able to process your data in a nice simple format, and tables are pretty good for that. So if I just quickly put on the little graphics there, so you can sort of see how each of those maps to the various original or the components which you might typically want to use with a standard Hadoop system. Pig doesn't really represent the Spark core, but I have to put it somewhere. It does cover basic data transformations that you might find. So when we're seeing the documentation, it did mention the various languages that you can use with Spark. Now, Spark was written originally or still is, in a language called Scala, and Scala is very similar to Java. So in Spark, you can write anything. In Scala, anything can be written. Any Spark code, any functionality of Spark is available in Scala. And it's very similar with Java. You can write code in, and we can also use Python, and now we can use R. And the reason we can do that is that for each of those languages, there is a specific Spark API which is being produced to integrate the Spark code with the code of the other languages. So Scala is the first language, and so it has complete functionalities. Because Java is so similar to Scala, it tends to have full functionality. This is, when I say functionality, I mean all of the facilities that you can do which are available in R, you can do using Java code or Scala code using the Spark libraries. Python, or PySpark as it's called, it came a bit later and doesn't quite have all of the functionality, although the main components are there, and frankly you'd probably do something pretty complex and unusual to find something that you can't do in PySpark and you would have to do in Scala. So it's not really much of a restriction using Python, and of course it's a big bonus if you're used to using Python, because of the way it's integrated. The Spark libraries for Python just looks like as if you've installed another package, installed another library in your Spark, in your Python environment. And it's similar with Spark R. Now Spark R is the newest addition to the suite of APIs, if you like. And again, it's written in such a way as to integrate completely with your existing R environment, and we'll see this in the examples that I'm going to give. Unfortunately, it's not quite as mature as the others, so at the moment there's no graphics integration with ggplot or other things that you might want to use in an R environment, and there's a rather limited choice of statistical analysis algorithms, but that will undoubtedly change as Spark progresses. So the demonstrations we're going to do are, I'm going to start off by showing you Spark running in a Windows environment, just using what's called the standard shell. In our case, we're going to use the Spark shell. You can use the Scala shell. You can use Spark R shell and various other shells, but we'll use the PySpark shell for that. We're then going to look at running Spark R in RStudio in the Hadoop sandbox, and we'll do various little examples using that. And then we'll run Studio on Windows with Spark R, and we'll look at different types of a couple of different type of files that you can actually load. So a file type, so JSON file type, and we'll load something from HDFS. Just before we get into the demonstrations, just a bit of information about the main data set that we'll be using. This is a data set from the UK data, available from UK Data Service. If you want to search for it, it's SN7348, European Quality of Life Survey, 2003-2012. If you want to download it, it is a very simple procedure to download. It's got approximately 105,000 records with 484 variables. What it's actually about, it's a survey has been carried out every 4 years since 2003, and it collects data on a range of issues such as employment, family life, home life balance, and so on. And I would say you can download it from the UK Data Service website. Now, although there's 484 variables in there, we're actually only going to use 5. And one of the examples we're going to give is how we extract our 5 variables from the 484. Okay, so we'll leave the slide for the time being, and we'll start on the demonstrations. Now, the first demonstration we're going to do is using the shell, and the shell is just pretty basic stuff, as you might expect. So what we're going to need to do that is a command prompt. Now, I've got a command prompt here on my PC. If you don't have that set up, if you, from the search panel down here, you can just type in command and click on command prompt. And this is a standard Windows command prompt, which of course, it being Windows, no one actually uses a command prompt, so it's quite possible you haven't seen this before. And from the command prompt, because I've already installed Spark, I can just type in PySpark. And over the next few weeks, we will actually be releasing a video and a guide on how to install Spark on your Windows machine if you want to try it out for yourself and follow along. And when it all loads up, you just get a little splash screen, I suppose, saying what version of Spark you've got. So we've got the default version 1.6.0, and you just get a little prompt. Nothing else. It tells you some of the things it's done. It's got something called a Spark context available as SC and a Hive context available as SQL context. Now, for this, all I want to do is demonstrate that this actually works. So what I've got in this notepad is some PySpark code, which is going to do a word count program. The word count program for big data is the equivalent of a Hello World program in almost any other language. If you learn any language, the first thing you'll do is write a little program which types back Hello World to you. Well, in big data, what you do is you do a word count of some document or set of documents or whatever. In this particular case, on my PC, I've got a copy of the Origin of Species. And these few lines here, in fact, these two here are the ones which do all of the work in the word count, and the other 3 lines, the output actually returns it back to Python from changes the RDD construct into native Python code representation of the output, and then all I'm doing in the last 2 is just standard Python to print it out, okay, onto the screen. So I'm just going to select those, go back to our command prompt and run them. Now what you notice is that the first line is reading the file here. These second 2 are actually doing the transformations I start off by getting rid of a lot of the commas and the full stops and so on. Whoops, too late, should have spoken a bit quicker there. And what it'll do is it will do those, and then it's just printing the results out, which takes quite a while. Obviously, if we're doing this for real, you'd send this to a file. But you can see even from this that I've got individual words, and at the end I've got counts. I'll just give it a few more seconds and it'll get to Z's. Because I know there's some Z's on the origin of species, so zoological and so on and so forth. So you've got various, so that's your basic workout. So that gives us confidence that our system is working. And that's really all we need the command prompt for. So we'll close that down. Now the next example we want to go to is using the sandbox. Now when you load a sandbox, it looks something like this, but you never bother about this. All you're interested in is this IP address, which I have used here. You can see it up here, that same address there, and that port tells me I want to use RStudio. And in RStudio, if you've used R before, you'll almost certainly have used RStudio, and it looks exactly the same, except that I'm using it from a web browser because the machine is actually effectively remote. Admittedly, it's on my same machine, but this address up here could be the address of a real Hadoop cluster somewhere in the cloud, or a very large on-premises one, or whatever. It doesn't make any difference. It just happens to be a sandbox in this particular case. Now, unlike the command line where you run a command called, say, PySpark or SparkR, those commands actually have a bit of code behind them which do a certain amount of setting things up for you. Now, because we're using standard RStudio, that setting up hasn't been done. So the first few lines of our script here is just effectively setting those things up for you. So when I run that, you get a few messages down here, and eventually when it finishes, what I'll end up with in the environments down here are our SC, our Hive context, and SQL context. So it's very similar to what we were getting before when we were running it in the command line. And it's just telling us that it's in there. These next three lines are really just set up for the graphs that we're going to draw later on. And that's just standard R, that's not Spark at all. So the first thing we're really going to do is we're going to read our data set. This is the EQLS one, which I mentioned before. This is a comma separate, it's actually a tab delimited data set, so that's why I need the delimiter tab there. It's got headers in it, so I'm saying it's got headers, and I want this readdf function to decide what the schema is. Schema is just the layout of the variables, names of the variables, and so on and so forth. So what all this statement, which is really a single statement, is just going to read the file in for me. And then as soon as I've read the file in, what I'm going to do is I'm going to select from that file of 484 variables just the ones I'm going to be interested in, which I neglect to show you in the slides. So let me just go back to the slides for a minute, show you that missing screen. I did zoom. You know, the five that we're going to use. So we've got Y11 country, which is 35 different various European countries numbered 1 to 35. Normal working hours for your main job. How much you use the internet. Is your household able to make ends meet? Now this is listed as it's like an ordinal value between 1 to 6. 1 means we can manage very well. 6 means we struggle to manage. So it's ordinal, and what we're going to count it as a continuous variable for the purpose of these demos. And the Q63 euro is your monthly income, which has been converted into euros, because obviously all 35 countries don't use the euro, so it's just been converted. So that's the selection of those 5. And then when we've done that, what we're going to do is, for this data frame here, we're going to say show me the first few or 6 records, if you like. Notice head is exactly the same command as you would use if you're using native R, but in this case this head is going to work on df2, which is a Spark R data frame. And when we get down to that far, I'll just run that now. When that runs, again, you'll get various messages coming out telling you the progress. Now this is running on the sandbox, and when it finishes running, you can see the first 6 records of that data frame. If we look up here, DF and DF2, they're listed here as former class data frames, and unlike normal R or RStudio, if these were normal R data frames, up here you'd have the little thing and you'd be able to click on it and see the table. You can't do that with these because they're not really tables as such at the moment, not as far as R is concerned. It's just an internal representation, but you can still do head on it, so you can still see what it looks like, and you can do other things as well. So let's consider an aggregation. So from our 35 countries, supposing we want to know for each country how many records are for each country, and this is the code we're going to run, and I'll just start that off running and I'll describe it. And basically it's just a normal summary of by country account of how many there are. Now notice how fast that ran, and the reason it seemed to come back instantly despite the calculations it's in theory performing is because it hasn't actually done anything yet. All Spark R has done is kept track of what needs to be done. And it's only when it's actually being asked to return something to the user that it'll actually get around to doing the work. And this command here, this collect command, is a way within Spark R of returning the formal class data frame into a standard R data frame, which is what we're going to do here. And as soon as we've done that, we're going to plot the results just using ggplot. So that the ggplot is just standard R code. We're doing the collect to make it into a standard R data frame. When that runs, we can see down here we have a standard little very simple graph, but you can also see here that the R country counts is now just a standard R data frame with the little view screen. We can look at that if we wanted to. Not much in it. Okay, now other things that we can do, I'm just going to collect the DF2 data frame, which was our original data frame, which has all of the records still in it. And I'm going to do a quick little plot of the monthly income, that's the Q23 euro, against how happy people are or how able people feel they can manage with that income. And when that finishes running, we get a very, very simple graph here. And really the only point of my showing you this graph is to show you that I've clearly got some very odd outliers up here, which are going to make a mess of any kind of analysis I'm going to do. So the next thing that we might want to do is to filter to try and get rid of them. So these statements down here are filter statements, so I'm just filtering back into the same data frame here, and these are just very similar to how you do in normal R. I'm saying what the data frame is, I'm saying what variable I'm interested in, and I'm putting some kind of condition on that variable. Now again, this is probably a better example. I'm doing 4 different filters there, but when I click run, it seems to come back instantly. And the reason it's doing that is because it hasn't actually done anything. It's only when I run the collect statement that we get the pause and it does actually do some work. And I'm also going to just add in another plot, exactly the same plot at the end, so we can see what effect all of this had on us. So again, it's not a brilliant graph, I know, but I've clearly got rid of the outliers and spread things out a bit. So on that basis, we're going to proceed and do a little bit of modeling. And what we're going to do is going to use GLM. Now again, GLM is exactly the same name as you would use in standard R, but this is actually the Spark R version of GLM, and therefore you use a Spark R data frame when you specify here DF2 rather than a normal R data frame. Other than that, the format of that command is exactly the same. And just like in an R, normal R, the result is also going to be an Spark R data frame rather than an R data frame, but I can still do a summary on it. So if I run that, it's almost as if you were just running a normal, you had normal data in R and you're running a normal GLM type function call on it. Now, although the data set we're using or started with is only about 112 megabytes in size, and I mentioned earlier the point about the integration with the likes of R and Python means that the code that you write is exactly the same. So although df2 is relatively small, so 6,419 records, 5 variables in it. If it was 1,000 times bigger and you needed to process on a large Hadoop cluster in order to get anything out of it, the actual code that you would write would still be exactly the same. You wouldn't have to worry about how it actually did it, how it made sure all the bits got back together and so on and so forth. And then at the end you just get your normal statistical type results of what came back. You can also get some predictions out of it and look at the results as well. So that works a very similar way, almost an identical way to what GLM would work on in standard R, except that we're using a Spark R data frame, and it wouldn't matter if this data set df2 was actually 1,000 times bigger than it actually is, provided you were running on a cluster. Okay. So finally, our final demonstration is again going to be using Spark R, but this time in the Windows machine, which I seem to have shut down. So I'm just going to start Spark R Studio. This is R Studio running on my Windows PC, but again, of course, it's a standard Spark R environment, so it all looks the same. And these first few lines which I'm going to run are almost identical, except here I've got a different location for my Spark home variable because now this is on my PC. So I just run that. And over here we will get exactly the same thing. There's no Hive context here because Hive hasn't been integrated into this version, but other than that it's exactly the same as we were getting before. And the first thing I'm going to do is read a JSON file. Now, again, this is a small JSON file which is sitting on my PC, and it's got some tweets from or about UK Data Service which I collected a while back. And you can see from here I've got my text file, formal class data frame, just as before. And one of the nice things you can do about these JSON files in Spark R is it will actually work out what the structure of the data is, and you can actually get it to tell you what it is. And this here is the structure of a tweet. And I've actually got that in this file here. This is just a cut and paste of what I did earlier, and you can just see how long and complex a structure you get when you're doing a tweet. And the problem with this is that if you're used to using tables, it can be quite difficult to extract information from this, because each level I'm going in here, in relational database terms would represent new tables, and you'd have to have links to those tables and so on. So this is probably why tweets are generally considered unstructured data, and you don't tend to use relational database systems in order to store or process them. But we've currently just read it into a Spark R data frame, and we can look at the schema. And just to show you how this would look if I convert it back just into a standard table, I can see what I'm doing here, that I'm just showing the structure, if you like, of this entities. And you can see from here, this output, that entities itself is full of sub-levels and so on and so forth. So actually extracting stuff from that could be a bit painful and tricky. But, oops, fortunately, Spark can deal with that. Spark and SparkR can deal with that. What we do is, despite the fact we know how complex this structure is, we tell SparkR this is a table in this line here. And having done that, we can use the SQL context in SparkR to treat it as a table and use SQL-like language to select variables from that table. So here, what we're going to do, we're going to select the created at, which is just the top level, ID, which is the top level. We're going to select text, which is also the top level. But also we're going to collect something called entities.user.mentions_name, which is now 3 levels in, and you use this dot notation to indicate the different levels. But you're just specifying that as if it was some long named variable. And having done that, we're going to put that into a table, and then we're going to look at the table. So when we run that, what we get back is, again, what is essentially just a table, our tweet hashtags with our 4 variables, and our name, which is our embedded field, is just shown as a single entity. In fact, it is actually a list because it's going to have multiple names in there. But again, you can just drill down to get whatever level it is you need to do, and the list you can just process as a normal R type list. And the last thing we're going to do, just to show that we can actually do it, this is the SparkR running on the PC, but it doesn't mean that the files that you're going to process are on the PC. So in this case, we're going to read another file called geography, and this file is actually located in HDFS on the sandbox that we were using before. So it's going to go to the sandbox. This is the address of the sandbox. That is within HDFS, and it's going to read the data in exactly the same way. And I'm just going to bring it back into a standard standard R data frame, and we'll just have a look at the beginning of that file. So the point of showing this is that almost regardless of how you've got your data stored or where it's stored, there is a way for SparkR or any of the other R dialects, PySpark or JavaSpark or ScalaSpark, to actually read that data and process it in quite a uniformed manner. Okay, and this is just the first few lines of that data. So back now to the slides, I think. Just to summarize a bit, I think I mentioned that Spark is still very much in development, and SparkR even more so. But you can certainly expect 1 or 2 releases a year, and so on, adding new functionality as we go. And certainly SparkR's got some catching up to do. At the moment, there is something called SparkR ggplot2, which you can download on GitHub if you're familiar with GitHub, and one would imagine that eventually that will find its way into the mainstream SparkR libraries. And also, I think I pointed out that GLM that I showed working a minute ago is effectively the only statistical analysis you can do in SparkR at the moment. You can do lots of other things in PySpark if you wanted to, but one would have to assume that as time goes by, all of those currently available algorithms in PySpark and ScalaSpark will come across into SparkR, at which point they will be structured in such a way that using them from R or SparkR is exactly the same as you would use them from their equivalent in the R libraries. So it represents an almost minimal learning curve for you if you're familiar with R already. So in summary, it's relatively new, and then the Spark is relatively new in the content development. The idea is that no matter what your needs are in big data processing, Spark will be able to do it using one or other of the provided API libraries. You can certainly use it. We've used it in in two different environments here, and of course in a commercial environment it will be used in large Hadoop clusters. It integrates very easily with the programming languages such as Python and R, and I think from the demos that we've done, hopefully that should be quite apparent to you. I mentioned more information. Well, again, we looked at a lot of these. We looked at the documentation. We looked at the programming guide. I told you that in these guides, when they give examples, they will give examples in all of the languages. So regardless of what you like to program in, you hopefully will be able to find an example of how to do that particular task in the language of your choice. I mentioned the Spark books, and there was a little list of them in that documentation section, but you need to be aware that because Spark is so fast moving, some of these can be very out of date. Well, they may be lacking the latest information. The core stuff will be the same, but for example, it's very hard to find a book based on Spark R, so you may have to go to the website of Apache and look things up from there. And certainly if you are going to do a search for information, it's always a good idea to specify the type of language, the language that you might want to find examples in and so forth.
I think we'll end the webinar there. Thank you, Peter. It's very good, and thank everybody for coming.
Thank you.
Thank you.
Bye.
Bye.